Hi there, during this session I'm going to be talking about how work done and energy gained or exchanged are related to each other. First off, talk about work. Work is the exchange of energy. Now how this is normally calculated in physics is work equals the force times the distance moved in the direction of the force. So work equals force times distance. The unit for work, therefore, is going to be Newton meters, but also remember this is the exchange of energy, so therefore the unit for work can equally be joules. A car is pushed with a force of 120 newtons for 10 meters against a resistive force of 20 newtons. Now here we've got to remember that the net work done on the car is 100 newtons times 10 meters, and therefore the total work done is 1,000 newton meters or 1,000 joules. Okay, so just remembering here that we're recognizing the total amount of force used to cause this change. It's the resultant force we're worrying about. So that's work done. Let's talk about energy now. Kinetic energy to start with. Kinetic energy is the energy of mass in motion, and it's calculated by half mv squared. V being velocity of the object, m being the mass of the object. So, if 50 kilogram person is running at 10 meters per second, they have 2,500 joules of kinetic energy. Now that is actually the energy needed to boil a teaspoon of water, to give you a comparison there. So how we calculate kinetic energy. Just a kind of a quick reminder here, in visual format we've got two diagrams, one of a car travelling at 50 kilometers per hour and one of a crash of a car travelling at 100 kilometers an hour. Now notice how it's travelling at twice the speed, but the amount of energy dissipated in this crash is increased by 4 times, because remember that twice the speed gives it 4 times the kinetic energy. Something just to remember there, and hopefully that will remind you of that fact, and also not to crash into walls. I think is good advice for everyone. Now, gravitational potential energy. So when we lift an object, we do work on the object. Now, the energy gained by an object is called gravitational potential energy. So thinking about our rules beforehand, work equals force times distance. Now the distance is going to be the height gain. The force is going to be us having to overcome the weight. So work is going to be mg times h. So therefore the gravitational potential energy gained is going to be mass times gravity times the height. Now another quick note here is relative to what? Well, as we think about height, gravitational potential energy is relative to a predefined zero. So wherever you want to allocate zero is going to be a point where there's zero energy. So the zero of GPE could be at the ground or it could be the top of the building. It just depends on the definition which you pick. The law of conservation of energy kind of joins all these things together. We've got to remember that energy is never destroyed, it's just converted from one form to another. So let's think about some examples. A battery converts chemical energy into electrical energy. An electric motor lifting an elevator converts electrical energy into gravitational potential energy. And when a moving vehicle uses its brakes to stop, the kinetic energy of the vehicle is converted into heat in the brakes. There's obviously often lots of other types of energy conversions taking place here. These are perfect scenarios, and the world is by no means perfect, but what we're saying here is that the energy is always converted into some other form. A common example we think about, okay, last one, nuclear reactor converts nuclear energy into heat. A common example we talk about is going to be conversion of gravitational potential energy to kinetic energy. So if an object's falling here, now its loss in gravitational potential energy, mass times gravity times height, is going to be equal to the gain in kinetic energy, half mv squared. So my elephant is going to be gaining kinetic energy as it goes down, moving faster and faster and faster. converting work to kinetic energy. If someone is doing work on a car and is pushing it, the force times distance, the work done causes an increase in speed. So in that case, I can recognize that the work done is going to be equal to half mv squared. So I can think about the work being done, and I can use that to work out maybe the velocity of the car at the end of this period of time. So that gives you an overview of work, kinetic and gravitational potential energy, how through the conservation of energy, all these things are often interrelated with each other. And hopefully that will give you some help.